Hello, my amazing students. We're talking today about two of my favorite subjects, the distributive property and the order of operations. And we're going to see how they work very shortly. But this is lesson 21 in your Saxon Course 3 book. And the first thing we want to talk about is on page 140 of your book. And it starts with the distributive property. But they're talking about perimeter of rectangle as an example of the distributive property. And they give you two different formulas that we can use for perimeter of a rectangle. It could be perimeter is twice the sum of the length plus the width, or perimeter is twice length plus twice the width. And we're going to see here that if we take a 12 by 8 rectangle, that's not a very good rectangle, but if we take a 12 by 8 rectangle and we do it with the first equation or formula, which is perimeter is twice length plus width, then we're going to obviously add the length plus the width together. The length plus the width added together is 20. And then twice 20 would be 40. Okay, hopefully we get the same answer when we do it with the other equation. Perimeter is twice length plus twice width. Twice 12 is 24. And twice 8 is 16. And 24 plus 16 is indeed going to be equal to 40. So it makes sense that we get the same thing both ways. But now we're going to talk about the distributive property, which is the one that turns this formula into this formula. Okay, so here is a little picture of what we're doing. So here is the first equation, twice the length plus the width. And it was equal to the second equation, twice length plus twice width. Therefore, since perimeter could be this or perimeter could be that, and they ended up both having 40, they were both equal, then we can say that these two expressions are equal to each other. They are. Okay, so how does this work? How are these equal to each other? It's through the distributive property. And the distributive property is basically going to have a parenthesis, and inside the parenthesis there's going to be an operation that's either addition or subtraction. Out here will be a multiple or a coefficient that we're going to multiply through, and we're going to have 2 times the sum of 12 plus 8 is the same thing as 2 times the 12 plus 2 times the 8. And then we had 24 plus 16 is 40. Here is the distributive property formally stated. If we have A times B plus C, that's going to be equal to A times B, which we can write simply AB, plus A times C, A, C. Or if we have 3 items in the parenthesis, we could distribute A times B, A times C, A times D, and then add them all together. So that would be AB plus AC plus, I ran out of room, AD. And indeed, we could keep on going. We could have as many items added together in this parenthesis as we wanted. And we would end up multiplying every single one of them by the number on the front. In this case, it's a variable letter. And lastly, sometimes we can have subtraction in here. So A times B minus A times C. Pretty cool. Now, the distributive property goes both ways. We can expand or factor using the distributive property. Now, if we started with 2 times something in a parenthesis, and we ended up with 2 times A plus 2 times B, that's called expanding. If we started with this on the left, and we pulled a 2 out of each one of those and put it in front, that is called factoring. And they're both correct ways. And can you see that they undo each other? Now, this is a fun little exercise to understand the distributive property better. Suppose we took these 2 rectangles, which are exactly the same size. This first one is labeled 3 times 8, 3 by 8. This one is a 3 by a 6 plus a 2. So it's the same rectangle split with a 6:2 ratio there. So suppose I wanted to find the area of this rectangle, and I could find it by multiplying 3 times 8, because we know area is 3 times 8, which is 24, length times width. Or we could find the area of this little one and the area of this little one and add them together, and that should be the same area. Well, if this across here up into that point was 6, and this is 3 for the height, then this larger portion of the rectangle would be 6 times 3, or 18. This smaller portion is just 2 wide and 3 high, because won't this be the same over here? If this is 3, then isn't this one 3 over there? And we're going to have 2 times 3 is 6. Now, if we add 18 plus 6, don't we get 24? Okay, so in this one, we added the 6 and the 2 together and then multiplied. In this one, we multiplied the 3 by the 6, and we multiplied the 3 by the 2, then we added them together. It's a very good picture of what is happening in the distributive property. Okay, so now we get to jump into the part that I just think is so much fun. Factoring is fun for Mrs. A. All right, so we're going to factor this expression, 15 plus 10. So when we're factoring, we're going to say, what do they have in common? Well, 5 and 10 both have a 15 and 10 both have a factor of 5. So I'm going to pull a 5 out to the front. And then I'm going to think, well, I've got 15 divided by 5 is 3, and 10 divided by 5 is 2. This would be the factored expression, 5 times 3 plus 2. Now, let's turn around and distribute it back again. 5 times 3 is 15. 5 times 2 is 10. When we factor an expression, we should be able to turn around and redistribute it and get back to what we started with. So you can check your own work. Okay, so this is example 1. We're going to expand 3 times W plus M. Okay, so it's going to be 3 times W plus 3 times M. I lost room for my M, but now can you see that if I wanted to factor this expression, I would say what common factor do they have? And they both have a 3. So I would pull the 3 out to the front, and 3W divided by the 3 would give me the W, and 3M divided by the 3 would give me the M. Anytime I factor an expression that I just expanded, I should go back to where I started. Factor AX plus AY. Now think about what you see in common between AX and AY. Hopefully you see an A in both of them. So we're going to pull out the A to the front, the common factor, And then we're going to say ax divided by a just leaves an x. Ay divided by an a just leaves a y. And this expression should be equivalent to this expression. We have factored. Now let's distribute and expand. A times x is ax plus a times y is ay, and we get right back to where we were to start with. This is example 2. It says expand 3x plus 2. If we expand 3x plus 2, we have 3 times x is 3x. 3 times 2 is 6. 3x plus 6 is our expanded expression. Now we're going to factor it. Shouldn't we go back to this? So we're going to say, what does 3 and 6, 3x and 6 have in common? They both have a 3. We pull the 3 out to the front. And then 3x divided by the 3 is the x. 6 divided by the 3 is the 2. And this is our original expression. So we expanded it, and then we turned around and factored it. Factor 6x plus 9. Okay, we look and say, what do 6x and 9 have in common? Is there a factor that we could pull out of both? And yes, there's a 3. So we're going to pull the 3 to the front. 6x divided by 3 is 2x. Plus 9 divided by 3 is 3. And now we're going to expand that new expression. 3 times 2x is 6x. 3 times 3 is 9. We get right back where we started, so we know we did it right. Okay, so now we have an expression. Wow, where do we start? So before we start that, we're going to look at the order of operations. Now, these rules that I'm about to teach you are universal over the whole world. We have all decided that this is the way that we will always do every math problem. So, what we're going to always do, if there is more than one operation to be considered, we will always do parentheses first, if possible. Then we're going to do exponents. Then we're going to do multiplication and division as we see them left to right. We're going to do addition and subtraction as we see them left to right. And PEMDAS is a good acronym. I grew up with please excuse my dear Aunt Sally. And so a lot of times they'll just say PEMDAS, but I like please excuse my dear Aunt Sally. You can use what you want as long as you do them in the correct order. So here we have that complicated problem. We say, okay, we're going to have to attack this problem using PEMDAS. P stands for parentheses. Brackets, braces are all grouping symbols. Even absolute value goes down as a grouping symbol. So when you're doing these, we've got brackets, braces. Oops, I never have been able to do those well. And absolute value are all up there with grouping symbols, just like a parenthesis. We need to do them first. Step 2 in the order of operations is exponents. Guess what? Exponents and roots, you're going to learn later on, are in the same family, and we're going to do them second. The third step is to do all multiplication and division as you see them left to right. Multiplication and division are at the same rank, so we're going to treat them at the same time. Then addition and subtraction are at the same rank, and we will treat them at the same time. They're number 4. Okay, so here we go. we're going to start. We're going to say, okay, parentheses, please. We're going to come over here, and we have one parenthesis to take care of. 7 plus 8 is 15. Okay, so we've got parentheses. Then we've got exponents are going to be next. We have 3 squared is 9. Okay, we have to do that next. So we have done 2 steps. Let's go ahead and write what we have left. 20. Take away 2 times 3 squared plus 15 divided by 5. Okay, so now we're going to multiply or divide left to right. So here we have a multiplication, and here we have a division. So we're going to do the leftmost first. 2 times 9 is 18. 15 divided by 5 is 3. Now let's go write what we have. 20. Take away 18 plus 3. Okay, and lastly, we're going to add and subtract left to right. So 20 minus 18 is 2, and then 2 plus 3 is 5. And the answer properly figured is 5. If you do that some other way, not using the PEMDAS, which is called order of operations, you will get a different answer, and it is the wrong answer. There's only one correct answer, and that is 5. Okay, so again, your book specifies that the brackets and the braces, that the braces are including these, but I've never seen any other book be so specific. So pretty much I've seen them used all different kinds of ways. So we're just going to not worry about which one is used where. We always use them in pairs though. You see how here's a parenthesis, and then outside is a bracket. And then outside that, oops, I didn't include it, but it's right over there, is the brace. Okay, so we always have them in pairs, and the starting and ending point tells us where we're supposed to be. So now we have another problem. This one is example 4. Okay, and yes, I put the brace in the right place. So now we're going to look and say, okay, I have quite a few grouping symbols. I have a parenthesis, I have brackets, and then I have braces. The order of operations for grouping symbols is always innermost to outermost. So we're going to always go to the very center of the inside of the most innermost. And then we're going to work our way out. So we're going to start with 5 minus 3 is 2. Okay. And then notice that inside here we have 6 minus 2. And 6 minus 2 is 4. So now I'm just going to put this in the little bracket because we have evaluated all of that. Now let's go ahead and put the brace here. The 8 minus the brace there and the 10. Notice how we're working inside out. So now we have to take care of this brace. 8 take away 4 is 4. So we have 10. Here's a 4 in the brace. 10 take away 4 is 6. We have to be very specific about how we go about these. Order is important. Okay, example 5 points out that absolute values are also grouping symbols, and we're going to do what's inside the grouping symbol first. So 2 minus 7 is -5. And then we're going to take the absolute value of that. And the absolute value, remember, is the distance of a number from 0. And -5 is 5 steps from 0. So that will be 5. But we did what was inside first, and then we did the absolute value. This is a radical. It's a square root. We always consider a square root as a grouping. In other words, we would never say square root of 9 plus square root of 16. We have to say 9 plus 16 is 25, and then we take the square root of 25. So that is almost considered like a grouping and kept together. Okay, the square root of 25 is 5, because 5 times 5 is 25. 5 squared is 25. And a division sign can separate items, okay? It can be used as a grouping. We would do everything in the numerator first, and then we would do everything in the denominator, and then finally we would divide. So 12 times 12 is 144, divided by 3 plus 3 is 6. So now at the end of the problem, we will figure out what the division is. We would not do it in pieces. We do everything in the numerator, everything in the denominator, and lastly, we divide 144 by 6. 6 goes into 14 2 times with a 12 and a 24 and a 4. So the answer would be 24. Example 6 is our last example and a fun one. Okay, so first our job is to evaluate this expression. We have to use our PEMDAS. Now we don't have any grouping symbols shown here. So we don't have any exponents. So aren't we going to skip down to step 3, which is multiplication and division? So we're going to look and say, okay, there's a multiplication and there's a division. So I have to do those first. 3 times 3, that's 9. So I'll go ahead and write the rest of this over here. Minus 3 divided by 3 is 1. So now left to right with addition and subtraction. 3 plus 9 is 12. 12 take away 1 is 11. So using order of operations properly, this expression is 11. The second part of this example says, now take the same expression, but put in one set of parentheses and make it equal 3. Okay, so you could go through and look at each one and say, okay, if I put a parenthesis here, will it equal 3? If I put a parenthesis there, will it equal 3? This is the trick right here. If we put a parenthesis around 3 minus 3, now let's see what our order of operations says. It tells us to go do this one first. 3 minus 3 is 0. So now we have 3 plus 3 times 0 divided by 3. Okay, so now we need to go left to right with multiplication and division. Here's a multiplication followed by a division. We do it left to right. So 3 times 0 is 0. 0 divided by 3 is 0. Okay, so all of this back here becomes 0, and we have 3 plus 0 equals 3. So that was kind of fun. That was showing how we could take one expression, and by just throwing a parenthesis in there, we could make it mean something different. Now we're ready to start our practice problem. So hopefully you have your practice set in front of you. We have 2 times 3 plus w. And we're going to expand both of these expressions. So remember, expanding is when we multiply the 2 into both of the parts. 2 times 3 is 6, plus 2 times w is 2w. Now, if we factor 6 plus 2w, by pulling out a 2, we should go right back to our original statement. Okay, 5 times x minus 3, we're going to distribute. 5 times x is 5x. 5 times 3 is 15, and there's a minus in between. Or we could attach the minus to the 3. 5 times a negative 3 is negative 15, isn't it? All right, so that is your A and B example already done for you. Now we just finished expanding, so now we're going to factor C and D. Okay, 9x plus 6. We think, what factor does 9x and 6 have in common? 9x and 6 have in common? They both have a 3. So we pull the 3 to the front as a common factor. 9x divided by 3 is 3x. 6 divided by 3 is 2. Now, to check it, we should be able to distribute this and go right back there. Let's try it. 3 times 3x is 9x. 3 times 2 is 6. We go right back where we started. 8w and 10 have only a 2 in common. So we're going to pull out the 2. 8w divided by 2 is 4w. Minus 10 divided by 2 is 5. 4w minus 5 times 2. Okay, 2 times 4w is 8w. 2 times negative 5 is negative 10, and it goes right back where it started. Okay, E says, which property is this demonstrating? Okay, illustrated. So here we have x times y plus z is xy plus xz. And that is the what? What we've been studying this whole lesson, the distributive property. Because if I take x times y and x times z, that's called distributing, isn't it? Okay. F. It says, why might we want to use the distributive property in this problem instead of doing what's in the parenthesis first? Well, to see that, we're going to do it both ways. If we do what's in the parenthesis first using our PEMDAS, then we have 30 take away 2 is 28, and 3 times 28. Oh, that's kind of hard to do, isn't it? Okay, so we're going to have to take 28 times 3 is 24. 2 times 3 is 6, 84. Okay, so it is 84, but because we have more tedious multiplication, it might take us longer than distributing. So let's distribute it. 3 times 30 is 90, minus 3 times 2 is 6. Oh, it's easier for me to take 90 minus 6 and still get 84 than it is for me to multiply 28 times 3. It's just faster for me. So both of them are correct because doing the parenthesis first and then multiplying outside is what we would do with our PEMDAS, our order of operations. But using the distributive property is certainly correct also. So we have a choice. When we actually can evaluate the parenthesis, we have a choice. And they should give us the same answer. And they do. Okay, here we have G in our practice problems. Okay, so we're looking for order of operations. We don't have any parentheses. We don't have any exponents. So we're going to jump right into multiplication and division. We don't have any division. We just have one multiplication, which we must do first. 5 times 2 is 10. 2 plus 10 minus 1. Now we're going to proceed left to right. 2 plus 10 is 12. 12 take away 1 is 11. And G is 11. Okay, H. Now, notice the same numbers are in H as were in G. But H has 2 parentheses. So I bet we're not going to get 11, even though we had the same numbers. And it's 2 plus 5, 2 minus, yep, it's the same signs on, everything is the same except there's some parentheses in there. So let's see what we get this time. We're going to do this parenthesis. Since it's a parenthesis, it's going to be left to right. 2 plus 5 is 7 times 2 minus 1 is 1. 7 times 1 is 7. And on this one, we got 11. And we got 2 different answers because of some parentheses. Look how everything else is the same, but the parentheses made them different. Okay, so now we are doing I. And I has lots of stuff. It has a parenthesis, and then it has an exponent. In fact, it's got 2 exponents in it. So let's start. PEMDAS. Please means we're going to do what's inside the parenthesis first. But inside the parenthesis, we have a 3 squared, which needs to be evaluated before we do anything else inside that parenthesis. So we're going to do this exponent before anything else because it's inside the parenthesis. So 3 squared is 9. 11 take away 9 is 2. So this whole parenthesis becomes a 2 times a 2 cubed. And then out here, we'd bring down the 4 plus 2 times 2 cubed. Now, what's going to happen first? The multiplication or the exponent? Please excuse. Excuse stands for exponent and root. So we're going to have to do 2 cubed before we do the times 2 here. So 2 cubed is 2 times 2 times 2, which is 8. So 8, there's the times. And we're just copying it all down again. Now we're at the multiplication and division step. 2 times 8 is 16. 4 plus 16 is 20. And 20 is the correct answer. There's only one right way to do it. And that's what PEMDAS does for us. Okay, so here we are with J. And J has got 2, it's got stacked parentheses in it, doesn't it? It has a parenthesis and then followed by a bracket. And we have to get all that stuff done before we can worry about this 10 out here. So we're going to go to the innermost parenthesis. 6 minus 3 is 3. So 8, take away 6 minus 3 is 3. Big bracket. Now we come to the next grouping symbol. 8 minus 3 is 5. And then lastly, we don't really need these brackets here for anything. They're not holding anything together, so we can take them apart. Now, if we had a minus inside, I would have left them there just so that we would know. But we didn't have a minus inside, so I can take them off. 10, take away 5 is 5. Final answer. K is another grouping symbol. We have a square root symbol, so we must do what's inside it first. 36 plus 64 is 100. So we have the square root of 100 is 10. That one was easy. L. We have the absolute value, another grouping symbol. So we do what's inside first. 8 take away 12 is -4. Absolute value of -4 is 4. Absolute value is the distance of a number to 0. Oh, I like this one. Okay, so we're going to have to evaluate a whole bunch of 2's and see what this equals. Okay, so we have no parentheses, no grouping symbols. So we're going to do our exponent first. So 2 squared is 4 plus 2 times 2 minus 2 divided by 2. Now we're going to do our multiplication and division left to right. So 2 times 2 and 2 divided by 2. 2 times 2 is 4. 2 divided by 2 is 1. So now we go write everything down. 4 plus 4 minus 1. 4 plus 4 is 8, minus 1 is 7. So our expression evaluates to a 7. Now we're going to have to put in 1 pair of parentheses to make the expression equal 11. So right now it's 7. We're going to erase everything and look at it carefully. What do we need to do to make it 11? Okay, so our parentheses are going to be right at the beginning and grouping the 2 squared plus the 2. All right, let's check Miss A's work. All right, so we're going to start with our grouping symbol. And inside the grouping symbol, we have a priority here, don't we? We have a 2 squared that needs to happen before the 2. So 2 squared is 4, and 4 plus 2 is 6. So this becomes a 6 times 2 minus 2 divided by 2. So we just write it all down. So now we're going to go left to right on our multiplication and division. We have a multiplication, we have a division. 6 times 2 is 12. 2 divided by 2 is 1. So it's 12. Take away, because that's a minus, 1 is 11. See how much fun these are to play with. And that is your last practice problem. We're ready to go on to our actual written examples. For our written exercises, the first one is kind of fun. It says, Bob drove from his home near Los Angeles to his destination in Sacramento in 7 hours. So that was his driving trip. Then it says, the next time he made his trip, he flew. He drove 1/2 hour to the airport, spent 1.5 hours at the airport, had an hour-long flight, and arrived at his destination 1 hour after landing. Considering Bob's total travel time, how much time did it save Bob to fly rather than drive? Okay, now 7 hours was driving. We had 1/2 hour at the airport, to the airport, 1.5 hours at the airport, 1 hour in flight, and then 1 hour between the end of the flight and his arrival at his destination. You know, you got to collect your bags, and then you got to get all that stuff and drive. So 1/2 plus 1 and 1/2, 1.5 plus another half is 2, 3, 4. So it took him 4 hours flying and 7 hours driving. So he saved 3 hours. If it was that short, I think I'd just drive, because I don't like spending a long time at the airport. But maybe I'm not Bob. Okay, number 2. It says George chopped 8 times in the first 30 seconds. 8 chops in 30 seconds. Okay? Then he chopped 5 times in the next 20 seconds. 5 chops in 20 seconds. Okay? And then finally he chopped 2 times in the last 10 seconds. So 2 chops in the last 10 seconds. So then it says, how many times did he chop? How long did it take him? When was he chopping the most rapidly? Oh, this is interesting, isn't it? Okay, so first of all, how many chops did he chop altogether? 8 chops, 5 chops, and 2 chops. So 8 plus 7 is 15. So altogether, he chopped 15 chops. 15 chops. Okay, and then it says, how long did it take him? 30 seconds plus 20 seconds is 50 seconds, plus 10 more seconds is a minute. So he did 15 chops in a minute. Now, maybe he's in some sort of chopping contest, because not very normally would you count how long it took you to do 8 chops, 5 chops, and 2 chops. But let's suppose that he was in a chopping contest. And so they had all of this very important data written down. So now, look at what they're doing. They're saying, how many chops, how many times did he chop? How long did it take him? When was he chopping the most rapidly? So it would make sense to me that he's going to chop the most rapidly when he first starts out on this competition, but maybe not. Let's see. All right, now, first of all, 15 chops per minute is his overall rate. Okay, that's what he did overall. In the minute, he did 15 chops. 15 chops per minute was his overall rate. But was there a time when he was chopping faster than 15 chops per minute? So let's go and put each one of these others over a minute. So we had 8 chops in 30 seconds. 8 chops in 30 seconds. Well, 30 seconds would go twice in a minute. So what if I multiplied the top and the bottom by 2? Then I would have 16 chops in 1 minute. Okay, so the very first rate was 16 chops in 1 minute, which was faster than his overall rate of 15 chops in 1 minute. Okay, so let's look at the next one. Okay, the next one was 5 chops in 20 seconds. Now, they made this pretty easy for us because all of these denominators go into 1 minute evenly. So 5 chops in 20 seconds. Now, what do I need to multiply 20 seconds by to get a minute? Well, 20 times a minute is 60 seconds. So we're going to multiply by 3 and 3. 5 times 3 is 15 chops, and then a minute. 1 minute. Okay, so the second set of chops wound up being the same as the overall average, 15 chops per minute. Okay, so far, it's what we thought, right? He started at 16 chops per minute. Then he slowed down just a little bit and got 15 chops per minute as his rate. Okay, and then lastly, let's take the 2 chops in 10 seconds. Okay, so the last rate was 2 chops in 10 seconds. Well, 60 seconds is a minute, so 10 times 6. So 2 times 6 is 12, in a minute. 12 chops in a minute. He is getting tired, isn't he? 12 chops in a minute is much slower than 15 chops, which was his average. Okay, so he started very fast, 16 chops per minute, and then he slowed down just a little bit to 15 chops per minute, but then he was getting pretty tired by the end, and he was only doing 12 chops per minute. Do you see how to compare the three rates? I didn't leave them at 8 chops per 30 seconds. I changed everything to where it had a minute on the denominator, and then I was able to compare the rates that he was going. Okay, so number 3 says, John read 66 books in 1 year. At this rate, how many could he read in 4 months? Okay, so he's going to continue at the same rate, 66 books in a year. But remember, 4 months is 1/3 of a year. So we're going to divide by 3 on the top and divide by 3 on the bottom to get the 4 months. 66 divided by 3 is 22 books. So he would read 1/3 of them by 1/3 of the year, or 22 books in 4 months. That was number 3. Number 4. It says, how can these numbers be rearranged to make the addition easier? What 2 properties did you use? What is the sum? Again, we've been playing with these for a long time. I want to get my 7 and my 13 together, don't I? Because that's going to make 20 and make it much easier. In order to do that, I'm going to use my commutative property first. And my commutative property tells me that I can switch those 2 around. So I will have 7 plus 13 plus 18. That's using my commutative property. Now I'm going to use the associative property and redistribute these. So I'm going to change the parenthesis from here to here, and that is my associative property. And then 7 plus 3, 13 is 20. 20 plus 18 is 38. So the sum is 38. Okay, so number 5 says, use the associative and commutative properties of multiplication to find the product of these numbers mentally. Okay, so we have 12 times 13 times 5 times 10. Now, I wouldn't want to have to multiply 12 times 13 because it would be longer, more tedious. What I want to do is I am going to move it to where I have the 12 and the 5 together, because 12 times 5 is 60, and that's easy for me. I'm going to move the 13 and the 10 together to get 130, because dealing with those zeros on the end is very easy. So I'm going to use the commutative property by moving the 13 and the 5 around. So 12 times 5 times 13 times 10 gets them in the right order, but then I'm not going to do them left to right. I want to do 12 times 5, and I want to do 13 times 10. So I'm going to put parentheses so that I can group them. That's my associative property. 12 times 5 is 60. And 13 times 10 is 130. And 13 times 6 is something I can probably pretty much do in my head. I've got 2 zeros because of the trailing zeros. 6 times 3 is 18, so I'm going to put down the 8, carry the 1. 6 times 1 is 6 plus 1 is 7, and I get 7,800 or 7,800. Okay, so the last practice we're going to do for you is number 6, and it deals with your distributive property. So it says Linda reserved 2 hotel rooms for $75 each room plus a tax of $7.50 each. Illustrate the distributive property by writing 2 ways to compute the total. What is the total? Okay, so she's buying 2 rooms. So she could start with 2 times the room plus the tax, 75 plus 750. Since they're getting 2 rooms for the family, okay, 75 plus $7.50, dollar sign. That would be one way to write it. That's the factored way to do it, isn't it? And we could expand that and get the second way to write it, which would be 2 times the $75 plus 2 times the $750. Okay, and I would probably do it this way on this problem simply because to me it's easier to double these since they have 5s on the end. So if I double 75, I'm going to get 150. Okay, if I double 750, I'm going to get $15. So 150 plus 15 is going to give me a 565. If I do it this way, it's not really that hard because I'm going to add the 7 to the 75 and then tack on the 50 cents. So that's going to be $82.50. Okay, and $82.50 doubled is going to double the 50 up to the next dollar. So 82 doubled would be 164 plus the doubled 50 is 165, and the 2 are equal to each other, aren't they? Okay, so we are done with lesson 21. We've done all of your practice problems and 6 of your written practice problems. We are done. So it's time for you to go do your homework. This is Mrs. A, and may God bless your day.